The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon. I'd like to thank you all for joining us today for our discussion on effective alarm rationalization. I'm pleased to say we have a good turnout. For those of you who may not know who Mac Solutions are, we are the creators of the ProcessVue Alarm Management Suite, which according to a recent ARC study is the most popular independent alarm management software used in the European power generation market. We offer software, services, and training in all aspects of alarm management, and we are based in the UK. My name is James Fox. Having worked for iMac, Matricon, and Honeywell in the alarm management arena over the last 20 years, holding roles in technical support, site engineering, and training, I'm now the UK and Ireland sales manager for the ProcessVue suite. Joining me on this webinar is Ian Brown, our Alarm Rationalization and Services Manager. Ian has many years' experience in the process industries in roles ranging from maintenance management, control system management, and consultancy. His expertise covers the alarm management standards and guidelines, and he is also a TUV certified engineer. With that, I would now like to hand you over to Ian, who will guide us through the main body of this presentation. If you have any questions, you can key them into the interface on your screen or wait until the end where there will be time for questions. Okay, Ian, over to you.
Okay, thanks for that, James. Good afternoon, everyone. In the UK time is good afternoon. I'd like to welcome you to the webinar on effective alarm rationalization. What is the secret to success? Hopefully, I'm going to give you some things to think about that might help you on your rationalization project. Some of the stuff you will know, some of it you might think, oh, I hadn't considered that. That's a good idea. So hopefully, we're going to introduce this to some things that will help you along the way. So, what is the secret to success? You've been tasked with rationalizing the alarms on your alarm system. You may have 20,000 alarms, you may have 5,000 alarms, excuse me. It could be a long, complex job. How long will it take? What do I have to do? All the questions you're asking. How do you maximize your chance of doing an alarm rationalization project and coming out with a successful completion at the end? What are the things you need to think about? Okay, hopefully I'm going to touch on some of the things, some obvious, some perhaps less obvious during this webinar. Okay, first of all, what do we mean by alarm rationalization? If we look in the alarm management standards, you will find alarm rationalization is defined as the process to review potential alarms based on the principles that you have put in your alarm philosophy to select alarms for design and to document the rationale for each alarm. Excuse me one moment. A quick cough there. Okay, so what we're talking about for documenting the rationale for each alarm. That means looking at the cause, the consequence, the operator response, all those kind of things, maybe some other information that you have for documentary requirements, the alarm setting. All of these things are being documented and reviewed for each alarm. So each alarm, for that read every alarm. So basically, at the end of an alarm rationalization process, you are going to be left with only the alarms you require to run your plant safely and effectively. That's all that should be left after you've rationalized your alarms. You're going to take away a number of alarms. So when you've got a lot of alarms, that's potentially going to take a long time. It's going to be quite a time-consuming process. So is it easy? Is it long? Can you make it any shorter? Can you shorten the process? Some companies, some people will tell you, oh, rationalization doesn't take long. If you use our methodology, you can reduce your rationalization time to just a couple of weeks. We can do that for you. We can help you. It's not a problem. Great, that's fantastic. Some people will say you can help to shorten the time you rationalize alarms by pre-populating your database with all the basic information about cause, consequence of missing the alarm, operator response, etc., so you can shorten your rationalization time. Do these things really stack up? Are they true? Okay, if you're going to document the reason for every alarm, the cause of every alarm, the consequence if you miss every alarm, for every alarm in your system, that's going to take a lot more than 2 weeks. No way you can get round not documenting those things. If you don't document, you've not fully rationalized your alarms. So shortening it to a couple of weeks, not an issue. It just won't work. What about pre-populating your database? The reason people say this will shorten rationalization time is what they really mean is instead of having a group of people looking at every alarm and typing in the cause, consequence, response, etc., while the reviews are carrying on, that group of people needn't be involved in the whole process. But the process of actually populating the database is still going to take the same amount of time. Someone still has to type that information in. So rationalization isn't going to shorten your whole project by pre-population because you will spend weeks, if not months, pre-populating a database before you can actually get to the team who are going to review the alarms. And when you do put that information, be very, very careful that the information you put in is actually the correct information. I have been provided with information to pre-populate databases in the past, and okay, we're ready to go. Our small team is ready to review the alarm. The first alarm comes on the screen, and the first question I'm asked is, what does that mean? Where does that come from? That's not what that alarm is all about, and that's certainly not what we do in response to the alarm. Why did you say that? It's the information you guys have provided me with. Well, it's wrong. So make sure if you're pre-populating, you actually have buy-in from a number of people that they review what you're putting in. So pre-populating doesn't really shorten the overall process, but it may minimize the time that people have to review alarms. Okay, pre-populate or not pre-populate, that's up to you. But what about rationalization? Lots of people will say, we only need to rationalize the top 10, 20, 50 nuisance alarms, or just the alarms that happen during startup and shutdown, because that's where our real alarm problem is. Or you may have been given a notification from a regulator that they expect you to document your high priority, your critical alarms. They expect you to do this work. So all we need to do is rationalize our high priority alarms. Okay, both those approaches are a bit flawed. Let's consider why you are there in the first place. Why are you going to rationalize your alarms? In all probability, it's because the priority of your alarms is incorrect. You've already identified. You have alarms that shouldn't be alarms. You have a lot of high priority alarms, perhaps, which in actual fact aren't high priority alarms when you look at them. So actually starting with high priority or the nuisance alarms, your plant runs. You've got a set of alarms which alarm but don't cause you any real problems. You're also going to document the rationale, if we remember our description, for each alarm. So that's every alarm in your alarm system. Not just 10 or 20 alarms, not just alarms that occur during startup and shutdown, not just the ones which are currently, probably inappropriately designated as high priority alarms, but every alarm. So rationalization is the whole thing, not just a small subset. You can say, I'm going to do a subset, but you've not properly rationalized all your alarms unless you do the whole lot. And what about those alarms that you miss? The ones that are currently designated as medium or low priorities. In all probability, the high priorities, the real alarms that are going to cause you some real issues, are the ones that don't happen all the time. If your real high priority alarms are causing you a problem, your plant would never run. Your plant would trip, it would shut down all the time. The reason that's not the case is those alarms that are going to cause you a big problem are likely to be currently designated as low or medium priority alarms. So rationalizing top 10, top 20, startup shutdown, that's not going to help you get to the root of your problems of inappropriately prioritized alarms, because the ones you really want are the ones you're going to overlook in the short to medium term by ignoring low and medium priority alarms. So really, to rationalize alarms, you really have to do them all. So what's the secret to success? Okay, one of the American presidents of years gone by was quoted as having said, "By failing to prepare, you are preparing to fail." And that's ever so true. So the basic secret to success is in your planning. But what is it you need to plan? What things do you need to think about? Some things are obvious, some things less obvious. So let's look at some of those things that would help you along the way. Before you begin, quite obviously, you need to have a published alarm philosophy. In the alarm philosophy, you will have the definition of what is an alarm. You're going to review the requirements of what are currently called alarms and decide whether they are alarms or not. Do I need to keep the alarm or get rid of it? Without a definition in your alarm philosophy, you can't rationalize your alarms. You can't prioritize them, because in your alarm philosophy, you will have a prioritization methodology based on consequence and time to respond. Typical table at the top of the right hand side of the screen there is a consequence matrix, the severity of consequence that will happen if you miss the alarm, don't respond to it. Associated with that, to the left bottom of the screen, is a small priority matrix based on consequence and time to respond. That will define your priority. You need that before you start rationalization. So if people tell you, I'm finishing the alarm philosophy, can you get on with rationalizing my alarms, please? No, not until your alarm philosophy is fixed and published and approved. In your alarm philosophy, you should also have a section, it's a requirement under the standards, for alarm rationalization. What terms of reference are you going to use while you rationalize your alarms? The more you're going to rationalize parameter-wise, the longer your process will take. Some people will say, I need to review and update every alarm descriptor. That's probably going to double the time that you need to rationalize your alarms from identifying if the priority is correct and whether it should or shouldn't be an alarm. What about alarm set points? Are you going to review all alarm set points? Or are you currently going to accept your plant is running, so let's take the alarm set points and leave them for the time being? The more parameters you add to your review, the longer your review process will take. So terms of reference, what are we going to rationalize? What are we going to review and update? How are we going to do it? That's your alarm prioritization and rationalization clauses within your alarm philosophy. Think about where you're going to rationalize. It's very easy to carry out rationalization on a plant, and people will tell you, it's great, we'll be in the control room, the room next to it. If we need to look at the screens, we can just walk outside. But if you're rationalizing alarms over a period of weeks and weeks, then someone is going to come and knock on the door and ask if Bill could pop out for 5 minutes. Generally what happens is Bill will disappear for the rest of the day. Your alarm review process grinds to a halt. If you're on site, it's likely to happen time and time again. Your review process is going to get extended. If you do your reviews off-site, less chance of interruptions. So think about where you're going to review your alarms. Also, who are you going to involve? Some companies will tell you they are going to maintain a core of knowledgeable and experienced operators, a control and instrumentation engineer, a facilitator. That's my core. They will review all the alarms. Okay, that's their process. That's their choice. Some companies will insist that they want to involve all of the operators so that they feel part of the process. Okay, that's great. No problem with that either. But just think who is going to be involved and when they're going to be involved. And let's consider, what about machines experts? Maybe you have a compressor or a turbine where there are specific things you need to consider when you're reviewing your alarms. Water treatment. Someone may be a water treatment expert. So think about the people that you're going to bring in, and especially a control system vendor or someone who knows your configuration. We'll come to that in a moment. So think about the people you're going to have to use while you're reviewing your alarms. And what about the tools? What tools would you need to review alarms? Okay, you're going to need something where you can read in your configuration, you can review your alarms and type in and document the rationale for each alarm. So you're going to need some kind of electronic database of some description. So tools potentially cost money. If it means someone's going to configure a tool within your own business, their time will cost money. The time required for operators to attend the review meetings is potentially going to cost money, because your senior management may have to accept that some roles will move. For the time being, that operator will be doing reviews. We'll bring in another operator to cover his time. So time and money, think about it. It's something you need to consider. It's something you need to budget for and plan for. Okay, tools. I mentioned the tools for the job. I mentioned some kind of database. Lots and lots of people, because Excel is easy to use, will say, I'm going to rationalize my alarms. I'm going to use Excel as my tool. Is that really a good tool? Yeah, maybe you can get away with it, but it's not really ideal, because rationalization, although it's not necessarily a one-off exercise, all the information you're going to document in your master alarm database with your reviews is there for the lifetime of your plant, for the life cycle of your plant. A spreadsheet can't keep values that keep changing. They only have one cell, one piece of information. You can't keep multiple values. You can't have an audit trail. So Excel is not really the right tool for the job. Something like ProcessVue Guardian, a master alarm database that includes tools for rationalization, is the kind of thing you should be aiming for. With ProcessVue Guardian, you can import data from several different systems, an RS3 system, a Yokogawa, an ABB system, into different parts of the database. You can create individual projects for each set of tags. So within a system, you could have a project for turbines, a project for compressors, a project for water treatment. So you can segregate the alarms. When you're reviewing the project for water treatment, you will bring in the man or woman who knows about water treatment, who can help you prioritize and identify what the alarms are for. When you do your turbine project, you can bring in the turbine export. So you can bring people in associated with projects. So it's great to be able to configure your system to accept projects. Or you can do them all at once. That's up to you. Once you have your individual tags, you're going to review information, you're going to change some parameters and settings, maybe the priority, perhaps a timer setting. Ideally, in your tool, you need to be able to copy that tag, that information, because you may have 100 valves. You review one, the other 99, we're going to make them all the same. So you want to copy that information. So you need to have the ability to bulk copy information that you've just reviewed. You need to be able to edit stuff, do a batch edit, a bulk edit. So your tool needs to consider and have all those functions and facilities. Your tool also should have the ability to prioritize the alarm based on your documented prioritization methodology. Your consequence grid, which is the grid at the top of the screen, the screen with the light cyan background there, that's your consequence grid. The grid at the bottom, the multicolored grid, that's your prioritization grid. You will select the severity of consequence from the top grid, the time to respond from the bottom grid, and that will prioritize according to your methodology and your alarm philosophy, your alarm. The right-hand side of that page is where you would document the cause, the consequence, operator response, whether it's a highly managed alarm. All that information is documented within this wizard. Your tool, whatever tool you're using, needs to have something like that to help you prioritize your alarms. And of course, something that an Excel spreadsheet won't have is an audit trail. What changes have been made, when were they made, by whom were the changes made. You need to have an audit trail, because don't forget, the data that you're putting into your master alarm database, the data you're using as the input for your rationalization review sessions, is used for the life cycle of your plant. So it's no good saying, I've done it once, I can forget all about it. You need to keep that data all the time. So you need the right tool for the job. So you have your tools, you've decided who you're going to invite. What else would you think you might need? Okay, P&IDs, drawings of your plant, cause and effects logic. Okay, that's useful. Maybe some user manuals for your compressor, whatever, your turbine. Maybe even screenshots of your control system. Some people would provide a file of screenshots so you can see where all the alarms are, perhaps see some settings. Okay, those are the kind of things you would take as the basic information. But what else would help you in dealing with your alarms? Anything else? Okay, what about when you have multiple fields within your configuration, configuring drop-down boxes in your tool? In here is a typical drop-down box from ProcessVue Guardian. In here we have given an alarm class with a drop-down box with 7 different entries. If you're typing communication alarm into your database time and time and time again, you're likely to get the spelling wrong. Computers don't like wrong spellings when you're reviewing and trying to find information later on. So consider putting drop-down boxes in. If your control system, for example, has an alarm enable, yes or no. Is it yes, Y-E-S, or is it a Y? Is no, N-O, or is it simply an N? If you put the wrong thing in, maybe your control system won't like it when you try and download. So drop-down boxes for consistency of entry and for accuracy. And what about your drop-down boxes if you've got lots of information in them? For example, engineering unit descriptors. You might have dozens of those. In this case, a drop-down box has been converted to be a lookup table within ProcessVue Guardian. In this case, we have, if you see on the screen, 845 pages of alarm descriptors, alarm messages. There are actually, at the bottom of the screen, 5,070 messages. You can filter, you can search for messages in the description box or the index, and you will get the same message that you want every time. There will be consistent input. So think about things like that for your tool. Does your tool provide you with these kinds of facilities to help your process go along? Okay. Before you begin, you've thought about tools and people. What about when the people first turn up? What are we actually here for? Training, obviously someone needs training in alarm management. You need to have the right people. But what you can do is set up a small presentation that happens before every alarm new group of people session. So in the presentation, you're going to define what an alarm is. You're going to remind people, reinforce the fact that an alarm must have a genuine response. If there's no response, nothing the operator can do, it's not an alarm. It should be an event, or it should be deleted, taken away. So reinforce that message. Just a half a dozen, 10 slides. Take 10-15 minutes at the beginning of your review sessions. Not every day, but when you get new people, useful to go through, just to confirm what you're there for. But be careful. Deleting alarms, if an alarm is not an alarm, it's either an event or no alarm, potentially. So, what if you delete an alarm? Just consider consequential logic. Some people, and I have to admit I used to do it, will configure control systems that when an alarm is activated, another piece of logic is activated. So when I get a high alarm, I will close that valve, I will start that pump, whatever. If you're using alarms and that is being used, consider if you don't have that alarm, that logic will never be activated. So just consider when you take alarms away, consider consequential logic. And that's where it's useful to have someone who is either a control system vendor who can look at your logic and tell you whether the alarm is needed for things you can't see, or someone within your company who actually knows the configuration. So just consider that as you're going through. Remind people that every alarm should provide adequate time for operators to carry out the response. If there's not adequate time, perhaps you need to reconsider whether it's an alarm or whether it should be an automated executive action through an ESD, through something like that. You're not going to design that logic as part of the review session, but you can make a note that that's something that's useful. Okay, you're also going to remind people that as far as reviews are concerned, you are considering there is a safe basis of design of your process. All your safety systems, ESD, fire and gas, they will function correctly as designed. So if the alarm is missed and the plant should shut down, the plant should shut down. If there should be a relief valve lift, the relief valve will lift. Confirm with people that you will not include alarms that compensate for faulty equipment or deficiencies in the process. That's not what alarms are there for. Alarms are not there to compensate. So just remind people about these things. 10-15 minute presentation is useful to go through. So you've thought about all that. You're going to rationalize your alarms. Have you thought ahead to when you've finished? How are you going to test and prove and validate that all the changes you've made, which could be tens of thousands of changes, how are you going to test and prove that they're all going to work? How are you going to download your output to your control system? Is the input exactly the same as the output? How do you get there? Consider how you're going to do it. It's no good doing 3 months or 6 months or 5 years of work only to tell your boss, we can't actually download this because we don't know how to. I don't think your manager will be very happy. They're expecting you'll rationalize your alarms and you will then install the updated configuration. So think about these things before you even start. It's important to know those things. And communicate with everyone. All the people that you're going to use, the control system vendor, operators, your senior managers, communicate with them. Keep open lines. You're going to have to treat alarm rationalization as a proper project. Put a project planner together. Who is going to arrive? So when we're reviewing our turbine project, I want my turbine man. I don't want my water treatment person. No, that's no good. They won't know anything about turbines. So set down the resources you need in terms of human resources. Who is going to be there, when, and what are you going to review? Do you need any other resources? Okay, so think about all those things and create a proper project plan. So now you've thought of everything, you're ready to begin. Okay? Is there anything else you might think of that would help you through the process? You've got all your documentation, you've invited everyone. What else could I do? Okay, you have, because you already have an alarm philosophy, a typical consequence severity grid. Here's a typical consequence grid on the screen at the moment for environmental safety, financial, and in this case, reputational consequence if we miss the alarm. Okay, so now we know when we have an alarm, we can identify the consequence. What's useful to do is actually look at typical consequences. So if, for example, an alarm might cause a plant trip, or you're working on a system where you have different levels of emergency shutdown, process shutdown, a turbine trip, a compressor trip, what is that actually going to cost you? How long it will take to recover from those trips, from those events? And what is the likely cost? Think about major things. It doesn't have to be absolutely everything, but typical things that will happen time again. If that alarm happens, it will cause an ESD level 3. If this alarm happens, it will cause an ESD level 3. You've already worked out where on your consequence level, large, medium, small, your severity will be. The actual priority will differ because some alarms you may have to respond to very quickly. So for the same consequence, it may be a high priority alarm. For the same consequence you have all day to respond, could be a low priority alarm. But at least you can identify and have a consistent approach, because believe me, if you use a lot of your operators to get them all involved in the process, one operator will say a plant trip, oh, we can recover from that in about an hour. Another operator will say, oh, that'll take about a day. All of a sudden, you've got inconsistencies. So if you can do something like this, it will help your process along. And then think about alarms themselves. What happens if you have duplicate alarms? So on the screen here, we have a vessel with a float switch, a digital alarm at the middle, and an analog alarm. Both are set to alarm at 800 millimeters. So every time the level goes to 800, you get 2 alarms. You have duplicates. As part of rationalization, you will take away duplicate alarms. Which are you going to keep? Okay, are you going to keep the analog because you like analogs and you can fit deadbands? Or are you going to keep the digitals because your float switches are tuning forks? You may use tuning forks, and they're really new. You can do lots of stuff to get rid of nuisance alarms. Make your decision. Keep a consistent approach. If you have dual alarms, which one are you going to keep? What about multiple alarms from a single source? This happened on a system that I was working on. 3 alarms were generated for every alarm. There were 3 high alarms for a high alarm. There were 3 low alarms. The system was configured with an analog input with high and low, which fed a PID loop with high and low. And it also fed an alarm block with high and low. Which of these alarms, if you come to this situation, which of these alarms are you going to retain? Which are you going to get rid of? Make a decision. For me, potentially keep the PID loop, because generally you'll have a little faceplate you can access from your operator screen where you can see the process variable. You can see the alarm settings. You're less likely to have the indicator feeding the PID or the alarm block easily accessible. You may be able to get them by typing the tag number in, but it takes time. So think about which of these blocks you're going to keep, which best fits your system, and maintain a consistency. What about trips? Low lows and high highs, which are set at the trip level for your ESD system. You have an analog low alarm. That's great. We know what happens when the analog low it goes. If I miss it, the system will trip. Okay. Is that an alarm or is it an event? Your system has shut down. The operator cannot prevent the system shutting down. That's what the low-level alarm is there for. He can prevent the trip. When the trip goes, the trip is not prevented. The operator is unable to prevent that from escalating. Maybe if it is a small part of a larger plant, it could be an alarm. Maybe if it's just a trip, it's too late. Maybe you want to make it an event. Think about this. Put down some rules. What about your protective systems? Fire and gas systems. Confirmed gas, for example. If you have confirmed gas, generally you're going to have a general alarm across your plant is going to be set off. For confirmed gas, that alarm is going to happen. There's nothing the operator can do for confirmed gas to prevent that alarm going off. Should that be an event or should it be an alarm? Do you need an alarm to tell you that the general purpose alarm is going off? Think about it. Put your rules together. Think about all these things with fire and gas systems. Similarly with ESD systems, what are you going to have? You may have, for either your fire and gas system, for your ESD system, a mimic panel on the wall which feeds into your DCS. Every time an alarm happens on the mimic panel, an alarm is replicated on your DCS. Duplicate alarms. Which ones are you going to keep and why? Document the reasons and keep a consistent philosophy. And ESDs. What about inhibits? If the operator goes to turn on an inhibit switch or click a screen where he puts an inhibit on the DCS screen, the ICSS, whatever you're using, does he really need an alarm to tell him he's just inhibited something? Probably not. So should there be events? Or if your panel is in another room, which someone else operates, maybe you do need an alarm. Okay, think about those things. These are the kind of rules you can set up which should be included in your alarm philosophy. So when you add a new piece of configuration, some more logic, we have an inhibit, that is a priority low alarm, an event, whatever your rule has been decided. So think about these things up front, because you will meet them time and time again as you go through your rationalization. And everyone will have a different opinion. What about out-of-range alarms for an indication on a screen? Does it matter if the indication isn't indicating? It's just an indication. Do you really need that? Think about it. If it's part of a control loop, is it going to trip your controller into manual and you'll get an alarm to say controller trip to manual? Think about it. Okay, put down some rules. When you create your rules, document them. Write all these things down. On the screen at the moment is a typical spreadsheet that I created for someone for a particular plant. We had a mimic panel on a wall for fire and gas. It was an offshore system. All the alarms were replicated to the DCS. The middle alarm on the screen there, the current priority was priority 1. We changed that to an event on the basis that the operator already responded to the mimic panel, had to stand up, go to the mimic panel, acknowledge the alarm. So why does he need to come back and sit down at the DCS to acknowledge alarm he's already acknowledged and taken the appropriate action for? We documented these things across a number of rules. That was actually Rule 17. We wrote everything down and presented it to our technical authority. If your company uses TAs or subject matter experts, whatever you call these people, the responsible engineer, document what you're going to do, why you're going to do it, present it to that person, the responsible person, and they can say, yes, they agree, or no, they don't agree. Go away and think again. But document everything, create these rules. It will help you as you go through your review process. Final prep, check the venue. Everything's in place. You're working in the room next to your control system. You're on site. I dislike that, but that's my personal preference. Okay, we need a projector. The projector's been booked out by human resources. They're doing a mind matter presentation. Oh, we have no projector. So just check that you've got everything set and you know everything's in place. Everyone's been invited. Will they turn up? Not necessarily. I worked with an offshore company, a company with offshore assets. All the operators were invited. The operators were employed by a third-party contracting company. The third-party contracting company, although they had all the information, they had all the invitations, they didn't change the operators' travel and accommodation plans. So when they all came off the rig, they went home because no one had changed their plans for them. And I had no one at my first review session. So just make sure that just double check that everyone really is turning up. You have your documentation ready. And of course, really important, you have your master alarm database ready, installed, populated, and everyone knows how to use it. That's really important. Before you start, do your little presentation, 10-15 minutes, just to remind everybody what you're doing, how you're doing it, the philosophy you're using, what an alarm is. Just carry out that 10-15 minutes before you begin. It will pay dividends, because anyone that has any concerns during that little presentation can say, but what about? You can explain, then they understand. Less hassle as you go through. So you're ready to begin your rationalization. You've thought of everything, thought of some things maybe you hadn't thought of. Just a couple of last words to keep you on track. What about a facilitator for your meetings? Useful to have someone that's going to run the meetings. That person needs to be knowledgeable and experienced, not only in the alarm management standards of what you're trying to achieve, but also the process that you have documented in your alarm philosophy of how you will rationalize alarms. The person needs to understand that process too. So they need to be robust. As you go through the meetings, all of a sudden someone will disagree, someone else will disagree, and an alarm review will start to expand past 10 minutes. 10 minutes is usually a reasonable amount of time, 10 to 15 minutes. You decide. The facilitator must get to that point in time and say, okay guys, we don't really understand this alarm enough. We're going to make a note of this. We're going to take this outside and review some information, go and collect more information. Let's move on to the next alarm. Because if your facilitator doesn't do that, your review process will just expand and expand and expand to fill the time available. He will focus on the agreed deliverables. This is what we're doing. Someone else will come in as an expert for some piece of equipment. Oh, should we not be reviewing these things as well? These parameters? Nope. Sorry. This is the process we're using. Those parameters we can review later. They're not essential to what we're doing. Your facilitator needs to keep people on track. So make sure you have a robust facilitator. And a facilitator, if it's an external person, is able to cut through internal issues. Sometimes you may find that people will start to raise an issue to make a point. Okay, it's not really about the alarms, it's about the way, oh, well, we would do that, but we can't because that's, if you remember, we've been told we're not allowed to do that. We've been moved on to this. We've been okay, yeah, whatever, but that's not what the alarm's about. Your facilitator needs to shut that kind of thing down. And sometimes an experienced and knowledgeable facilitator will ask questions that to the room potentially seem dim. That's a silly question, but it's the question that's on everybody's mind, and nobody wants to ask the question because they'll look as if they don't know what they're doing. Or perhaps it's a question that's a little bit touchy, and the facilitator needs to ask that. So think about an independent facilitator. It really is a helpful thing. Okay, so you've thought of everything, you've got a facilitator, and you can carry on reviewing your alarms. You've got your tool set up. Really, they're the basics, the real basics that would help you have a consistent, effective rationalization process. So I don't really have a huge amount more to say other than that hopefully my webinar has been of use to you. Hopefully it's made you think of some things that perhaps you hadn't thought of. If you want any more information or assistance, the details of Mac Solutions and myself are on the screen. Please feel free to contact. We can help you with anything from authoring your alarm philosophy to helping you rationalize your alarms, to reviewing alarms, to nuisance alarm remediation. We can help you with all those things with your alarm rationalization process. So the details are on the screen. More than happy to help if you contact me or Mac Solutions. I'm finished for the moment. All I need to ask now is to say thank you for attending and ask James, have any questions been raised, James? Any questions that, as we've been going through the webinar, people weren't clear about, or have another question to ask? Over to you, James.
Thank you, Ian. Some very useful information there. Okay, we will now open the presentation up for questions. If you do have any, please either raise your hand and I will unmute you, or you can key them into the interface and we will answer them. No questions so far.
No questions so far. Okay. Well, if anyone does have any questions, the details are on the screen. You can contact us if you're very shy and don't wish to raise questions through the webinar.
Okay. Well, thank you all for attending. We will be in touch with details of our next webinar soon. And in the meantime, we will get this one uploaded to YouTube. So if you wish to watch it again, you can do so on there. It should be up in the next few days. We will also have a white paper on this subject soon, which will go into more detail. This will be available on our ProcessVue website. If you have any further questions or wish to get in touch regarding improving your alarm systems, then please do get in touch. Thank you and goodbye.
Goodbye.